Okay, class. So we're gonna start the lecture now. Today we're gonna talk about limits more, and then we're gonna move to the continuity next. So the idea for today is we are going to learn how to compute limits in the case that we need to use squeezing theorem, and we're gonna summarize everything about what to know about limits, and then we're gonna move to the continuous property later. So this is actually section 12.3 in the book when we talk about limits. So this is a notation that we use for the two-dimensional limit. As you learn on Monday, this is going to be the case that fxy go to L when xy goes to AB. Here, the good thing about the limit in two dimension is you can actually use a thing that you learn in calculus 1. So the limit of constant c. So you're gonna get the just constant c. And if you see x and y here, because x and y they are continuous functions, so you can plug in a or plug in b inside the limit. It's simple like that. And you can use all limit theorems here. On Monday, what we learn is if you see the limit that you're trying to plug in numbers and you get 0 over 0, you can solve for this limit by using factoring or conjugate. There is no L'Hopital rule in two dimensions, but actually you can use L'Hopital rule if you can reduce the form into one dimension, but in two dimension you don't have the L'Hopital rule. And now we already learned how to do conjugate and factoring for the questions about limit. And we also learn the new concept in two dimension, that is because in two dimension you have so many lines that you can go to AB here. So it means if you can find two different lines that the limit does not that the limit they are different, so you conclude immediately that the limit does not exist. Or if you find one line that the limit does not exist, so the limit for at this point it's gonna be does not exist as well. This is a case that the limit does not exist. You can see that you have to pick different the line that pass the point 0 0, and eventually if you can find two lines that they give you different limit, you conclude immediately that it does not exist. Okay. Today we're gonna start from page 17 here. We're gonna learn another useful theorem to compute the limits here. So this is called squeezing theorem in two dimension. Squeezing theorem in two dimension. Let's first see the statement of the squeezing theorem in two dimension. So the statement of the squeezing theorem in two dimension is if you have condition number 1. So if you have fxy to be a function, and then you know that this is less than or equal to m, you take absolute and it is less than or equal to m for all xy near x0 y0. So if you know that fxy can be bounded by some number m near the point x0 y0, and number 2, if you know that the limit of function g equal to 0 where xy go to x0 y0, then you can conclude that if you have number 1 and number 2, then we conclude that limit of f times g gonna be 0 as well. F xy times g xy is equal to 0 when xy go to x0 y0. So this is assumption that you have to check number 1 and number 2. So if you have number 1 and number 2, you can conclude that the limit f times g is gonna be 0. This is going to be useful for the case that when you see the limit and then you're trying to pick the line and you always get 0 0 0 0 0. So basically it's probably to be the case that it's actually 0. In this case you have to showing that the limit is indeed 0 by using the squeezing theorem in dimension. So this is the idea. So the idea is when you know that fxy is between m and negative m, right? It means absolute fxy less than m. If you know that absolute fxy less than m on the top right, so it means fxy going to be between minus m and m, right? And if you multiply fxy by gxy, so fxy going to be in between m gxy and minus m gxy, right? So the idea is if you start from here on the top, you take the absolute value out, so you get this, and then you multiply g, so you get that g. And by squeezing theorem, you know that this term and this term, if they go to the same value, so it's gonna force that in the middle you have to have the same thing. This is less than or equal to, okay? So if you know that the one that I highlight in green, they go to the same number, so it means the middle one gonna go to that number too as well, right? From the squeezing theorem, which means if we have the condition that the limit of g equal to 0, it means this is actually 0. This is actually 0, and it's gonna force that the limit f and g gonna be 0. F times g gonna be 0. This is why we call it squeezing theorem, because once you have number 1 and number 2 here, you can conclude that the limit of the product of f and g gonna be 0. So how do we use it? So how to use? So once you see fxy and gxy in the question, once you how to use? So when you see the function, when we see the given function that we want to compute limit, so we try to split the function into two pieces. Split the function into two pieces called f and g. Once you split it to two function f and g, then you're trying to show number 1 and number 2. Then we show number 1 and number 2. Once you can show number 1, number 2, then you're done. So by squeezing theorem, the limit of f times g is going to be 0. Okay, we're going to have 2 examples at least for the first 15 minutes here. But this is a theorem for squeezing theorem into dimension. Okay, so ready to do example? So let you jot down for a minute for those of you who still working on the slides. So you can see that it's useful when the case that you have limit equal to 0, g equal to 0. Because if the limit g equal to 1, for example, this thing gonna be bounded by m and negative m. It's just mean nothing because you cannot conclude the inside here. So you wanna conclude the limit inside here. So it's gonna be useful when this equal to 0 and this equal to 0. So it's bounded by 0. Alright, so let's do the example. So we have limit xy go to 0, 0, 2x square y, 2x square y cube over x square plus y square. So first of all, we're trying to plug in the limit here. So 0, 0, you plug in over there. So you plug in 0 inside there. So you get 2 times 0 square, 0 cube over 2 square plus 0, 0 square plus 0 square here. So it's actually 0 over 0. So it means that you have to do something, but you actually know that the factoring and the conjugate will not work, right? Because these two, they are These two technique you cannot use it here because you cannot factor it here, or you have nothing to do about the conjugate. So it forces you to do something else. So once you know that you cannot factor in and conjugate, so you have to pick the line. But if you try to pick x equal to 0, y equal to 0, x equal to y, or x equal to y square, or whatever the line that you pick, so you're gonna keep getting 0. You can try at home, like you can pick like so many lines and then you're gonna get 0. For example, if you pick let's say you pick x equal to 0, so the limit gonna be 0 on the top over 0 square plus y square. This is the limit is actually 0. And if you pick y equal to 0, it's gonna be 0 over x square plus 0 square here. It is actually 0. If you put x equal to y here, so once you put x equal to y over there, so you're gonna get 2x to the 5th power over x square plus x square. And then once you cancel everything, so you're gonna get 2x cubed. This is going to 0 as well. So we try to do C1, C2, C3, and keep going. You're gonna get the same pattern that the limit gonna go to 0 always. Because the bottom part you only have x square and y square. The bottom part you have x square and y cube. It seems like the top part you have something that is more heavier. So something this is that the degree gonna be higher than the bottom part. So anyway, so when you cancel it out, this one should be just x cubed, right? When you cancel it out, so you're gonna get x to the something, which once you take limit 0 0, xy go to 0 0, it's gonna go to 0. So it's always go to 0 here. So that made you think that maybe the limit is actually 0. This is the scratch word. All right. Once you think that maybe the limit is actually 0, you have to use squeezing theorem. So we're gonna try to use the squeezing theorem here. So how do you use it? So first of all, we're gonna start by 2x square y cube over x square plus y square. We're gonna separate this thing into two pieces. So first here and second here. So the first one you're gonna name it fxy. The second one you're gonna name it gxy. So you're trying to separate this thing into two pieces, f and g. Your goal is that once you separate the limit of fxy, oh no, sorry, the limit of gxy, but the first one, fxy, you need, once you take absolute, you hope that you can bound it by some number. And number two, you need the limit g go to 0. So what is going to be your f? So the idea is, I'm gonna show you how to do it pretty quick here. So we're gonna start by taking x squared plus y squared here. Put it on f1 here. And then we're gonna save x squared here. We're gonna come back y, we need to keep this thing. And then 2y cubed here. So you can see that we're gonna save some part, which is this part, to be my f, and then the next part to be my g. So if I do that, so my f gonna be x squared over x squared plus y squared here. And then this number gonna be less than or equal to absolute x squared plus y squared over x squared plus y squared, which is equal to 1. So now we can prove, we already proved that condition number 1 holds because fxy gonna be less than or equal to 1 for all xy near 0 0. So it's okay because it's actually bounded by 1. And then the function g that you pick, it's gonna be limit g is gonna be 2y cubed xy go to 0 0. This is simple because you plug in 0, you get 0. And then conclusion, so by the squeezing theorem, by the squeezing theorem into dimension, squeezing theorem, we conclude that the limit of f times g, which is the limit of the given function, it is actually 0. We're gonna come back and talk a little bit about the technique how to pick f and g. But first of all, let you jot down and understand the mechanism of the squeezing theorem first. So again, one more time, we split to two function f and g. We're gonna need f to be less than or equal to some number here, can be any number you want, and then the g part here gonna be 0 here. So the technique is that we gonna always put the denominator with the f, because this is easy when you make a bounded function here, because the trick one, we're gonna save the denominator, save the denominator at f part. So you can see that we're gonna just start by I see x squared plus y squared. I'm gonna move it to f here, and then I take x squared here to the f part, because I know that I need to use x squared here, because when I bound it, so I'm gonna have x squared plus y squared here. This is actually greater than, because when you have something x squared and then you add something non-negative to the top part, it's gonna be bigger, right? So this means x squared plus y squared gonna be bigger than x squared. I need this form because this is actually, when you cancel, you get 1. And then that is fxy. And your g here gonna be the remaining part that you have left. And then that's y going to be just the g part here. Well, there are more than one choice here that you can do. If you wanna move number 2 to here, that is okay as well. So you can do this thing to be 2, 2, 2, and then 2 as well. It's okay as well if you want to do that. So there are more than one solution. Does it make sense? Some of you say that, Ajahn, can we do something other than this? If you do y cube here, if you do y cube here, it's gonna be different, because you cannot bound it by something like this. So y cube is not less than x squared plus y squared. So it's gonna be harder for you to bound the top part here. So you have to think critically, what are you going to pick for f here, so you can bound it by the term here. Make sense? Alright, it looks hard at first, but the technique gonna be the same on all questions. So pick f first by saving the denominator to f, and then trying to simplify until you get this form, and then it's gonna be cancellation at the end, so you get some number 1. Okay, so now let's practice more squeezing theorem on example 8. How about limit xy go to 0, 0 of 3xy over square root 3x squared plus y squared? What if I want to use a squeezing theorem for this question? So what should I do? 3xy over square root 3x squared plus y squared. Okay, we're gonna split it to two, f and g. This is my f, this is my g. Okay, you need some part to be your f, some part to be your g. But our goal is that once you pick it, so you want your fxy to be bounded by something, right? So as I told you, that the first technique that we do is we trying to keep this thing to be 3x squared plus y squared here. We keep the denominator in the f part first, because we know that at the end what we're gonna do is we're gonna say fxy gonna be square root 3x squared plus y squared here. It's gonna be here. How do you bound it? This one, what are you going to pick here? This is the challenge part, that which one do you gonna use it here. So we're gonna do, at the end you need square root 3x squared plus y squared square root 3x squared plus y squared. If it is this one, it is good, right? Because it's gonna cancel and then you get 1. So how can you bound it's gonna be bigger than something? So you can say this one gonna be bigger than, if you keep the same thing here, 3x squared plus y squared. On the top part, which one is smaller than the right hand side? This is always positive, right? This is always positive. Then if I say delete this one, is it okay? Should be okay, right? So you're gonna say, oh, this one less than this one for sure, because this one gonna be big, right? This one gonna be bigger than or equal to 0. So y squared gonna be less than 3x squared plus y squared for sure. This is why this is okay. And then this one, once you simplify, it's gonna get back to just y. Does it make sense? This is why we say, okay, we're gonna keep y here. We're gonna keep y here. We're gonna keep 3x here. So once you do that, fxy gonna be absolute gonna be less than 1. This is one way to do it. If you don't like it, you can say, oh, Jan Kap, can we do number 3 here as well? You can. Because if you do number 3 there, so you're gonna have number 3 here, 3 here, and 3 here, and 3 here. It's gonna be bounded by 3 anyway. So it's like any constant doesn't matter, because you're gonna just keep it with you anyway. So this time, to make it clean, so I'm gonna just do it this way. So just make sure that I have 1 as a constant here. And then now step 2, my limit gxy, it's a limit 3x, which is actually 0. Right, so it's actually 0 now here. So by the squeezing theorem, the given limit is 0. This is how to show the squeezing theorem here. Alright, so to sum up, you learn 3 ways how to compute, which is factoring or conjugate, or choosing the line that give you different limits, and also you learn how to use squeezing theorem. Alright, let's do the summary first. How to approach the limit question. So limit fxy. When you see the question, you're gonna be asked how to compute limit fxy. Go to something here. So what you're gonna do first, the algorithm gonna be step 1. You plug in x0, y0 and see if the limit is some number L or not. If it is some number L, you conclude that it's the limit. And this is a step number 1. If it is not, you're gonna go to step 2. If not, you go to step number 2. Step number 2 is that once you plug in and it doesn't go this way, you're gonna get 0 over 0. So you have to use factoring or conjugate, as I told you. If you cannot use factoring and conjugate, so you're gonna pick the line. Step number 3. Picking the line. This is the step that you can show Picking the line, this is going to be the step that's gonna show you that the limit does not exist. So you have two ways to do it. First one, you can find one line that the limit does not exist. Then you conclude that the limit does not exist. Or you can pick two lines that you give different limit. So the limit does not exist as well. So the step should be like this. And the last one, if not, if you feel like, oh, อาจารย์ครับ we picked so many lines and then you keep getting zero. So step number 4, you can apply squeezing theorem. The squeezing theorem here gonna be the case that you have to pick limit f and g equal to 0. Let's do the two conditions. So condition number 1, you have absolute fxy less than or equal to m, and then g limit go to 0. So once you can prove this too, so the limit gonna be actually 0. Limit fg gonna be 0. So this is the algorithm for computing the limits. Does it make sense? To compute the limit here, 20% of the final here, just gonna be computing the limit. 30% gonna be on differentiation, and 50% gonna be integration. Because integration is much more interesting. Limit and differentiation is like easy. So final gonna be like 20% gonna be limit question, 30% gonna be differentiate, 50% gonna be integration. Integration is just you just need to draw a lot of pictures because it's like in two dimension. Okay, so we're gonna practice a little bit. So let's show you how to get the limit question in two dimension. Let's try to do the hard question together. So this is the, okay, you jot down this one first. This is the summary for limit question. Okay. This one is it okay? This one I just pick the exercise from calculus to like Thai for Thai student. This is actually the exam for Thai student from last year. So let's see if you can do it. The limit of, this is the hard question for last year. So find the limit x, y going to, well, before I type something, but I delete it because I want to just give you harder question. So find the limit, but this is, well, this is a challenge one, but I mean, it's hard to think about this question, but like the solution is not, it's actually simple. So find limit of x, y going to pi over 4, 0, because this is actually interesting because pi over 4 and 0 is just like the point that we are not familiar with. And then we have tan x plus 2y minus 1 over 4 pi, 4x plus y minus pi here. Find it if it exists. Otherwise, can you show that it does not exist? So first of all, we're gonna try to plug in this thing. So we plug in pi over 4 and 0. So on the right hand side, this is my scratch work. So we're gonna plug in, we're gonna get tan x to be pi over 4, and then minus 1, and then 4 times pi over 4 plus y minus pi. So it's actually give you tan pi over 4, which is 1, right? Minus 1, so you get 0. And the bottom part, you get pi minus pi, which is actually you get 0 over 0. So for sure, you cannot just plug in. And with the function tangent here, you don't feel like you want to conjugate or factoring because of tan here. The tangent here gonna give you a hard time to factoring or conjugate, right? Hard time to do factoring and conjugate. So we're not going to do factoring or conjugate because tangent gonna give us something super hard to do it. So we're gonna pick the line. Then what line do you gonna pick here? So You can see that we follow step. We plug in and then we get 0 over 0. We don't use this one because it's super hard. So we're gonna pick the line. If I pick the line and I keep getting the same number, so we're gonna use a squeezing theorem. So here, what line can you pick here? The first one is, you can pick the line C1 first. Pick C1 to be, you need any line that pass the point pi over 4 and 0. So what is the first line that you can pick? Y equal to 0, right? Because it passed y equal to 0 for sure, right? Because you need pi over 4 and 0 is here. The line y equal to 0 is this line, so it's gonna pass this point for sure. So we're gonna do the line y equal to 0 first. So limit x, y going to pi over 4, 0. This is on C1. On C1. So you're gonna get tan x minus 1 over 4x minus pi, right? Because you plug in y equal to 0 already. This one you already plug in. Already plug in y equal to 0. So you plug it in. So what is the limit of tangent x minus 1 over 4 pi minus pi here? 0 over 0, right? Because you plug in here, you already plug in y equal to 0, so it actually have this thing left. But pi over 4 here, x go to pi over 4. This is actually, or you only have x left. So this is the same thing as you said, this is limit x go to pi over 4 because there is no y left. So it's the same thing. Tan x minus 1 over 4x minus pi. So what is the limit here? 0 over 0, right? But you have to use the L'Hopital rule now. Because this is actually come back to one dimension. Because there's no y left here, so you only have x left. So you can apply the thing you want now in calculus 1. So you can apply the L'Hopital rule. So we're gonna differentiate one time. Dip tan, you get sec square. And then dip the bottom part. This is actually dip, you get 0, and then you get 4 minus 0 here. Now you have sec square x over 4. This is by using the L'Hopital rule. And then you plug in pi over 4 next. So the answer is gonna be sec square pi over 4 here, which is cosine pi over 4 is cosine 45 degree is 1 over square root 2. So yeah, and then sec is gonna be square root 2. So this is square root 2 square over 4. It's actually 1/2, right? So the limit on C1 is actually 1/2. It's a little bit tedious in terms of you have to plug in y equal to 0 first, and then it's gonna come back to one variable, and then you apply the L'Hopital rule. This is only C1, so we pick C2. You need challenge question, I know, because this is like x equal to pi over 4. This is another line that you can pick because x gonna go to pi over 4, y gonna go to 0, right? This is the thing that another line that you can pick x equal to pi over 4 or y equal to 0, right? This is the first two lines that you can pick, and then you hope that once you do this, it's gonna be okay. You can apply the L'Hopital rule after once you pick x equal to pi over 4. This is on C2. So once you plug in pi over 4, you're gonna get tan pi over 4 plus 2y minus 1. And then over you plug in pi over 4. So you're gonna get only y on the bottom, right? Because you plug in pi over 4 here. So cancel, and then pi minus pi, so you get just y here. So So you only have y here, the top part you're gonna have that one. Now again, one more time, this is actually come back to the limit y go to 0 tan pi over 4 plus 2y minus 1 over y, because this is actually the one dimension now, because you have no x left, because you already plug in x equal to pi over 4. So you use L'Hopital rule one time. So dip tan you get sec square. But L'Hopital with L'Hopital rule, so you get 2 here, right? Because you have 2y inside there. So you differentiate one more time and then minus 1, and then you get 1 here. Oh, minus 1 disappear because you differentiate, sorry, you differentiate it. So you differentiate tan, you get sec square, and then by the chain rule you're gonna have 2 inside there, and then minus 1 disappear, differentiate y, you're gonna get 1. So here, this is the L'Hopital rule. And then once you plug in 0 here, this is gonna give you different number, right? Compared to 1/2. So you're gonna have 2 times sec square pi over 4, which is actually 2 times square root 2 square, and this is actually 4. Different number. So once you pick y equal to 0 and x equal to pi over 4, it gives you different limits. So actually the limit does not exist. Because this and this, they are not equal to each other. Sounds good? I think you can follow it, but it's gonna just, you know, like, once you listen to it, you understand, but it's gonna be the challenge one when you do the exercise in the book or something. If you see harder question, can you do it by just from the scratch? The thing is that the easy way that you're gonna pick the line is just you trying to pick the one that is simple by just picking the line that pass the point on the horizontal way and vertical way. This is the way that we usually do it first. If not, we're gonna do this way. We're not going to go with the different with the harder line or something like that.
So normally we choose two lines, a vertical and horizontal line that pass through the point. Then after that,
Unless you see something like x squared plus y to the 6th power or something, maybe you have to pick x equal to y cubed to balance the degree or something. It's gonna show you, like, you're gonna see it in the question like last time, that here you have to pick x equal to y squared, so it's balanced the degree here. Alright, so let's do one more harder question.
and it's half hollow.
No, we're gonna need one more, and then I'll give you a short break.
That sounds good.
Let's do one more that I exercise 10, because I already delete the old one in the slide because it's way too easy. So let fxy equal to xy square root y plus x cube. I just copy from Thai class. X square plus 2y square. This is when xy is not equal to 0, 0. It's gonna be 0 when xy equal to 0, 0. Then find the limit of fxy. Okay, you need to compute the limit here. let's make it more simple by just delete x cube here. So we're not going to just, okay, let's do this one. So example 10. So what if you want to find the limit of x, y go to 0, 0 of this one? So first of all, we're gonna just start by trying to plug in the value, and you, of course, if you plug, you're gonna get 0 over 0, and there's no way that you can factor and conjugate here, because inside here you seems to be no way to factor, because the bottom part is not in the form that you can factor out, because you have plus sign, not a minus sign. And then now we're gonna trying to pick the line, right? So we're gonna pick the line. If you pick C1, x equal to 0, so the limit gonna be actually 0 over 0 plus 2y squared. It's actually 0. If you pick C2 to be y equal to 0, so you also get the same thing. So you get limit equal to 0 over you plug in y equal to 0, x squared plus 0. And then you can try to pick the line x equal to y or y equal to x. So you're gonna get the limit x square square root x over x square plus 2x square. This one gonna give you the limit of 3x square in the bottom. The top part gonna be x to the square and then square root x. So it's actually x square gonna cancel out. So you're gonna get square root x over 3, which gonna give you 0 as well, right? Because x, y go to 0. You can try another line. For example, maybe we're gonna try x equal to y square or y equal to x square, for example. You're gonna have limit x, y equal to x square if you simplify this thing, it's gonna be limit x to the 4th power on the top, right? Because you have x square, and x gonna be x to the 4th power. The bottom part you're gonna have x square plus 2x to the 4th power. Is that right or wrong? Am I right? So y equal to x square, y equal to x square, y equal to x square. But this one x, y go to 0, 0. So you're gonna just get limit. You pull out x to the 4th power. So you're gonna get let me try. Can we do that? No, because it's gonna go to x, y, x to the 4th power plus, this is 0 over this is 0 over 0 now. And then let me double check the function here. Okay. What we can do is we can move x to the 4th to the bottom part first. It means that the limit does not exist, I guess. 1 over x square over x to the 4th power plus 2, right? And then it's actually limit 1 over x square plus 2. And when x go to 0, what happened? 1 over x square, you're gonna, yeah, this is going to be the big one, right? Infinity, and infinity plus 2 gonna be infinity. So 1 over infinity, it's gonna be 0. So it's actually 0. So if you try so many line here and then you keep getting 0, 0, 0, 0, so now you feel exhausted, like maybe the limit is actually 0. So we're gonna use the squeezing theorem instead. Actually, you don't have to pick this line if you feel like, oh, Jan Cup, you get 0, 0, 0 and keep get, and then you can just, oh, maybe I should try squeezing theorem instead. This question will be okay if you use squeezing theorem, because picking the line is so hard because you're gonna get 0 all the time, and then like at some point you should stop and do the squeezing theorem instead. Alright, so we're gonna start by xy square root y over x square plus 2y square. We're gonna split it into two things, f and g. And then we're trying to apply the squeezing theorem. So what is going to be our f? What is going to be our g? For sure, what we learned today is keep x squared plus y squared with you on the f part, because it's gonna be your f. But what is your g then? F and g, the remaining part here. So fxy gonna be square root x squared plus y squared here. How would you bound it? What are you going to pick on the top part? The simple way is you pick x first. Once you pick x here, but at the end you need to have something x squared plus 2y squared here. If you have this one, it's gonna be less than it's gonna be 1, right, at the end. But this thing, this is bigger than, this is actually bigger than x squared over x squared plus 2y squared, right? But this x less than x squared, do you think it is okay to use x less than x squared? Is x less than x squared always when xy close to 0, 0? Maybe not, because if you get 0.1, no, this is like 0, 0.01, right? So x is not less than x squared. So this is not okay to pick x. What else you can pick if you cannot pick x? Well, it's gonna be the same thing, right? If you pick y, so y cannot be less than y squared, and then how would you bound it? So this is the idea that we're gonna pick x and y together. Let's come x, y together here, and then you're gonna have x, y here. We're gonna do square root x squared square root y squared. Is that okay? Because x is square root x squared, y is square root y squared. And now this is actually equal sign, because x equal to square root x squared, y equal to square root y squared. And then now we do this thing less than or equal to square root x squared square root y squared. Well, because I can add 2y squared here, it's okay. I can add 2y squared here, the blue part, because it's always, this term, it's always bigger than this term, right? And then for y squared here, I can add one more x squared, one more y squared, so it's going to be the same thing. So at the end, you're going to have square root x squared plus, because I add this thing, so it means the second term here going to be bigger than this one for sure. And here it's like that, and then now everything gonna cancel and then you get 1. This is ridiculous, like which is like so hard to if you don't see the technique for the first time, it's gonna be super hard to do it. But the technique is that once you pick one x or one y and it does not work, maybe pick them together and then use the square root to help, and then at the end, once you have 2 square root, you group it out again. It's gonna be the same thing as the denominator, and then you cancel. All right, so number 2 is limit g. Okay, what you have left about g is square root y. Just kick it to there. Square root y. Limit of square root y. Y, x, y goes to 0, 0. Actually 0. And it's mean by the squeezing theorem, limit x, y square root y over x square plus 2y square equal to 0. By this squeezing theorem. You can see that at the point 0, 0, we don't use it. We don't use the function here at all, so it doesn't matter. So we just only care this one, because when x, y go to 0, 0, it means we care about the behavior near x, y equal to 0, 0. Okay, so we're gonna have a break here, and then we're gonna come back to talk about the continuity for 40 minutes more. So about 30 to 40 minutes more. We're gonna have the break until 11:10, I guess. Just give you 10-minute break. So 11:10, we're gonna come back and learn 30 more minutes about continuity until we finish. We only have 5 slides left, so which is good.
Only 5 now.
Okay, so it should be good by 11:40, I guess. Okay, so let's take 10-minute break, everyone. Now we're gonna come back and talk about continuity.